LEETCODE! It's time to do what we have to do. LEETCODE. Having struggles with your relationships, struggling with depression, struggling with life. LEETCODE is the answer. So now, let's go back and explain pre-order traversal in a binary search tree. Pre-order traversal. It goes from always root, left, right. I'll say it again. Root, left, right. So say that we have this 8 is our current root. I repeat, 8 is our root. So what we do is we always do root number 1, go to the left side, 2, and 3, lastly, and going to the right side. This is always the order we have to follow for pre-order. Root, left, and right. Okay? Why are you asking why I am so aggressive today? Because I am excited to solve LEETCODE. However, another rule what we have to do while solving LEETCODE, I mean not while solving binary search tree pre-order, is when we get to a new node, we reset. For example, let's just say we do root left right, right? So we do 1, 2, 3. After we say we add 8 or print 8. And by the way, traversal just means going through all of this. So going through this whole binary search tree is just what traversal means. So when we print 8 or like store 8 or add 8, whatever you want to do, but we just need to do 8. After you finish this, you go to number 2, 3. However, when you go to a new number or a new node, you put that as our new 1. And I told you before, the left is going to be 2 and the right side is going to be 3. So it resets. So we're going to add 1 again. So we're going to put 3 here. I'm going to put 2 and 3 here. So again, we go to our 2. However, when we go to our 2, this is going to be a new set, I would say. So it's going to be this 1 and these null are going to be 2, 3. So we're going to cross this out and 2, 3 out, right? So it's going to go 8, 3, 1, right? Basically, that's how it's going to add, print, or do. But in binary search tree pre-order traversal, this is how it works. So when we do since the red crosses are what we have finished, we go to our 3 now. Because this is our most, we don't go to this 3. I'm gonna try to circle it in blue. We don't go to this 3, we go to this 3. Remember, we always go to the most recent call. And this is going to be our new, again, 1, 2, 3. So what's gonna happen is we're gonna add 6, 6, 4, and 7. 6, 4, 7. Now these two are null. So these crosses out, obviously. And now we go to our 3. Remember, we still have to do this side. So what we do is we now, since 10 is our new 1, it's going to 1, 2, 3. So we're going to cross out this part, 10. Now we're going to do 14. 7, 10, 14, 13. And this is how binary search tree works. And in order traversal. So all we really need to do is we always start from our root. And then remember, LEETCODE. We not LEETCODers. Dear viewers, I mean, we always start from our root. Then we go to the left of our root, and then we go to the right of the root. However, when we go to a new root, that root is set as 1. In a new kind of set. For instance, this is going to be 1, 2, 3. After we finish our 8, where we did here, we go to our 3. But when we arrive at a new number, that number is always going to be a new set. So it's going to be 1, 2, 3, relative to the position here. Okay, if you guys have any questions, please leave a comment. And we are back! How y'all doing? How y'all doing? So, first thing we have to do, in question 144, is not copy this method, but I'm copying this method for solving the question. Okay? So, let's go to 144. Let's read it real quick. Given the root of a binary tree, return the pre-order traversal of its node's value. So basically, what we have to do, 1, 2, 3, right? So we're gonna print 1, 2, 3 in order of in-order traversal. I mean pre-order traversal. In a pre-order traversal, what always happens, as I told you before, we always grow from root, left, right. So root is going to be 1. We're going to go to 2, and we're going to go to 3, and so on and so on. So it's going to be similar in example 2, and let's get straight into code. So we want to return a list of integers. However, in binary search trees in pre-order traversal, we are going to use recursion. But when we reason why we are going to use sorry, that's a tongue twister there. We reuse recursion there is because we want to add all the values basically. When we add all the values and finally return them, what we want to do is we want to do it recursively. However, when we do recursive, we want to return a void. Okay? So what we're going to do is it's going to be easier when I explain it. So let's just say this is our main method, right? And outside of this method, we're going to create a list. So list of integer, let's just say anything is going to be good, x1, just for in this case. X1 is usually less1, new array list. So we're going to create our array list right here. And what we're going to do is we're going to do pt, we're going to call this method. And in this method, what we're going to do is we're going to add all the values in our basic array list. So we're going to do root and x1 right here. So in here, what we're going to do, as I said before, I'm going to put array list here. So until now, let's just go over what we did. We created an array list, and we created some sort of method outside of our main method, which is this, because we wanted to call it recursively. So basically all we really need to do in this case is when if root equals null, we are going to return. And since it's void, we're not gonna return anything. And except for that, what we're going to do is pre-order. Again, the root always goes first. So x1.add root.val is going to go first. And the next thing we're going to do is we're going to call this method recursively. We're going to go always to the left side, and then we're going to go to the right side. Okay? Root.right. So pre-order, probably less pre-order. In this case, we're gonna call this, and we're gonna finally return our x1. So what this method does is we're going to add the first file. So let's just use this or example 2. So it's gonna add 1. Okay, it's gonna first add 1. We're going to go to the left side. Now when we arrive to the left side, as I said again, it's going to reset. 2 is going to be 1, 4 is going to be 2, 5 is going to be 3. So we're going to add 2, go to 4, and so on and so on. So so the reason why recursion is so effective is you don't really need to think about it. Okay. And we created another method here because we wanted to just add all the values into our array list basically. And that's why we created an array list here. So if we just look at our code real quick before we submit it, let's just try to run this. Yes, it's gonna be correct, and let's try to submit this. Yeah, it's gonna be 100% correct. So again, if we just go over what the code is basically, so we create our array list outside of our list. I mean, not list, our list here, right? Because we want to return this. But what we have to do is we're going to create another method where we add all the values. Okay, we're always first going to add the root val, then going to our left side, then going to our right side. If when we finally reach null, for instance, if we go from 1 to 4, and then after 4 we have obviously null, two null values, right? Just like these numbers like 6 and 7 before 5, there is actually not a value but two nulls below 4. So when we hit null, we're going to return that. And we're going to go to 1, 2, 5 basically. Yeah, that makes sense. 1, 2, 4, 5. Yeah, we're going to go to 5. And how we're going to do that is through recursion root. So always go from left and then right. And if you submit this, this is obviously going to beat 100%. And guys, if you have any question regarding on this question, please leave a comment. Thank you so much. Have a great day.